All right. So on number 1, which of all the formulas that we have learned should we use?
E.
The one with the E. Why?
Continuously.
Continuously. Whenever you see this, we are going to use E. So A equals P E to the power of RT. So what are we substituting in for P? $2,700. That is the starting amount, the deposit amount. A is equal to 2,700. What do I put in next? What comes after 2,700? The E. Remember, when you see continuously, we do not use parentheses and a 1 plus. Whenever you see continuously, we use E. What are we putting in for the rate? 0.046. I take 4.6%, divide it by 100%. That gives us 0.046 for our rate. Where does that go? Exponent, 0.046. And then what else? 10, yes. Multiply by our time, which is 10. And when you put all that into the calculator and you hit enter, after rounding appropriately, if you need to, we get what? 4,276. And how many pennies?
Could you just say 4,227?
No. Oh, yes, you could say 4,277. 4,276 and 99 cents, or 4,277, depending on how you round that one. I would accept either answer. Number 2, write everything you know about the red graph. So there's 2 graphs shown there, a blue one and a red one. I know you guys don't have colors, but there's colors up here. So the blue one is f of x equals 5 to the power of x. G of x we don't have an equation for. How many equations are there for g of x? What'd you say? 5 equations?
Oh, wait, no. 1, 2.
There are 2. There are 2 equations that mean the same thing. They're just written differently. So I can write g of x equals, what's the base on the blue graph on f of x? 5. So g of x equals 5. And then what would I change so that it was decay? Negative to negative x. How else could I write that equation so that it would still describe the exact same graph, but it looks different? Not a y equals. I'm still writing an equation for g of x. Here's my f of x. I'm still writing an equation for g of x, but what comes after the equal sign is going to look slightly different. What else could I write that would look different but mean the same thing as 5 to the negative x? 5 over 1?
Negative 1.
5 over negative 1 like this?
No, over, out of
1 over 5. Would I have any negatives here at all? No. To the power of what? X. A negative exponent would take the base and turn it into the reciprocal. How would you describe the transformations that are happening here? It's what? It went up 5 from the blue graph? We're starting from the blue graph. I want you to describe how the red graph has been transformed from the blue graph. Reflect. Reflect over what? Over the y-axis. Is the red graph showing us growth or decay? Decay. How do we know it's decay? It's decreasing. It's going down. It starts really high on the left, and then it drops really quickly as we move to the right. We always read our graphs from left to right, just like you would read a sentence. Is there anything else that you could tell me about the red graph?
It's the asymptote is 0.
Asymptote is 0. So what does that look like if I write the whole thing out?
Y is 0.
Y equals 0, yes. It has a horizontal asymptote. I'm going to abbreviate that. At y equals 0.
Don't we do the because it goes up, it keeps going with infinity, but it doesn't go down any more than where it's at?
We could write domain and range, yes. What would the domain for the red graph be? For all my exponential functions, what would the domain be? All real numbers. And then what you were talking about, Mikey, is the range. What's the lowest this graph ever goes?
0.
0. What's the highest the graph ever goes? Infinity. Is there anything else at all that you could tell me about this graph? I see one other thing that I could do.
What is that word when they like cross?
Special point on here that sometimes gets named. Y-intercept. Where's that y-intercept at? At 1. So we have a y-intercept. Was that what you were thinking of? Y-intercept at 0, 1. That is probably everything I can think of to write down here about this graph. Do you guys have any questions about either of the problems on the bell work? We use our rules of rounding. Now, grocery stores, banks, they will round a little bit differently, and I don't know all of their rules, but in here we're just going to use like the normal rules from elementary school. But if you don't round it, if you just chop it off, I'm not going to take off points. All right. Yesterday, last thing we did was number 5 in your final exam review packet. So we are ready to work on number 6. Did you need anything else off of there? I'm okay. Thank you. All right. Number 6 is asking me about transformations from the parent. What am I looking at if we're talking transformations?
The H and K.
Yeah. A, H, and K. First thing I always identify is the base, because the base is not A, it's not H, it's not K. What is our base here? 6. Three is what? 3 is the A value. What does that do to the graph then? Stretch it which way? Stretch it this way or stretch it this way? Vertically stretched. By how much?
3.
By 3.
Wait, I have a question.
Yes.
You have to always put by how much?
Yes. If you're saying a vertical stretch or a vertical compression, you got to tell me by how much. Just the same way you wouldn't just say left or right, or up or down, you would say left how far, up how far. Is our A value going to do anything else to the graph?
No.
Why doesn't it reflect it?
Because it's not negative.
Because it's not negative. All right, so we've talked about everything A is going to do to the graph. Is there an H value?
Yeah.
What is it?
Negative. Oh, no.
Yeah, no, you were right. It's -7. Because what I see right here is the opposite of H. So H would be -7. What would that do to the graph? It's going to shift it left 7. H shifts things left and right. Will H do anything else to my graph? No, it only ever goes left or right, and it can't go both ways. So then I move on to K. K is -2. Goes down 2. What else does K tell me about? The asymptote. What will my asymptote be? Y equals -2, because it's always Y equals K. Nice work. Domain. This is going to be for all of my exponential functions. Doesn't matter what the base is, doesn't matter what A is, what H is, what K is. All real numbers. So -infinity to +infinity. Or you could write that with that R symbol. For the range, we talked yesterday about 2 ways of knowing what the range is. If A is a positive number, then the range would be whatever K is to infinity. And if A is a negative number, it's going to be -infinity to whatever K is. So which one of these cases applies here? Top one. Our A value is positive. So what's my range going to be? -2 to infinity. Yes. Quick question. Okay. Oops. All right. You guys have any questions about number 6? No. Number 7. We've got 4 parts to number 7. Anytime we have a story problem, we're going to be using one of the equations from up at the top of the page. For part A, which equation would I use? A equals P. You said 1 plus? Or minus? Yes. Okay, let me write this down. Plus or minus R over N to the power of NT. Absolutely the correct one. What was the key to knowing we had to use this one? It says compounded, and then it's followed by monthly. I've got an LY word back there. But that LY word is not continuously. Since it says it's compounded monthly and we have a formula with N in it, what will my N value be? 12. Remember, it's how many times in a year it happens. Compounded monthly. How many times in a year is it happening if it's happening monthly? 12. Yep. All right, so A equals, what are we using for P? 7,000. And then parentheses, 1, and then would I go with the plus or the minus? Because we can't use a plus minus, I got to pick one. Plus, why plus? You're absolutely right. Deposit tells me that that's what they started with, but how do I know it's a plus?
Because it's how many in 4 years, so you're adding money.
There's a key word that I'm seeing so that I know it's going up in value and not down in value.
No.
Interest, what's the interest doing? Go right before the word interest.
Pay.
Pays. Abby deposits in an account that pays. It's the account that's doing the paying. It's putting money into Abby's account. If someone is paying Abby, her amount goes up, right? That's what I see there. This is telling me that Abby has an increase. So I know it's going to be a plus here. Then we have our fraction, r over n. What's the n going to be? What is n, the bottom of the fraction?
Oh, 12.
12, there we go. Where else will I put a 12? Yep, out here. Okay, now let's get to that rate. You guys were giving me the rate first. And I know why, because normally we write the top of the fraction before the bottom. What is the rate? What are we putting on top of the fraction? What do I have to do to this number before I can use it in my problem? Divide it by 100. So what do I get when I divide that by 100? 0.054. This is what we're using for R. 0.054 would be fine. I'm going to write 0.054. One last thing I need here. What is that? T. What is T? 4. Because here it says 4 years. It's kind of split between two lines, but I know it's referencing the time there. Yes. Yes, you may. So 12 times that 4. So grabbing our calculators, we're going to put it in now. And how much money will Abby have in her account in 4 years if it is compounded monthly?
8,683.
8,683, and I'm sorry, I didn't hear the pennies.
50 cents.
50 cents or 51 cents, depending on how you round it. I would take either one. 50 or 51. That's not an exponent. It has to be an exponent. On part B, what formula would I use? Same formula, and you know that how? We're changing the n. It still says compounded. This time it says quarterly. N equals, it's not 25, it's 4. When we say we're going to cut something into quarters, whether it's a year or a dollar or a piece of cake, it always means we're going to cut it into 4 equal-sized parts. So quarters always is going to mean 4 of something. So So everything about this first one is exactly the same, except that n value. So I need to recopy everything that I wrote above. Or not above, but off to the side in part A. And I need to make a change here and here. We're going to put 4 in instead of 12. So I'm going to type it in almost exactly the same into my calculator, except the bottom of the fraction is different. And what I'm multiplying as part of the exponent is different. $8,675 and 17 cents. Absolutely correct. All right, so we've used this formula for part A. For part B, what formula do I use for part C? Same one, why? It's weekly. We still see compounded. I see my LY word. How many weeks are there in a year? 52. On Friday, when you go to take your test, if there is a question that says weekly on there and you don't remember, you've got test brain, you're like, I know we did it in class, but I do not remember how many weeks there are in a year, raise your hand. If you say, what is n for this problem, I won't tell you that. But if you raise your hand and say, how many weeks are there in a year, I will tell you that. If you don't remember how many there are in a year, or quarterly, how many quarters in a year?
Why don't you just put like a little thingy on it?
Because I want to know if you know how to interpret these things. Part of what I'm looking for is, do you know it means that many in a whole year? Because one of the things that I've seen happen a lot is on weekly, some people will put 7.
Isn't it like 58?
It's 52. Why do you think some people put 7 on weekly?
They're thinking of a week.
They're thinking 7 days in a week and not how many weeks in a whole year. Does that make sense? Okay. So absolutely everything is the same as A, B, and C, except for which pieces? My n value. My n value is now what? 52. So back into my calculator I go. Yes, 8,686, so 8686 and 74 cents. On A, B, and C, we used the same formula, but did we get the same answer on all of them? Which one was the smallest of these three? B. Why is it the smallest? Because it's quarterly, and what was our n value? 4. That's the smallest n value we've had up here. What was the biggest n value we've had so far? 52. Was that one the biggest total? Yes. Was it a lot bigger than the others? 8686 is a lot bigger than the other two? No. It's like, what, 3 1/4 bigger than this one? But it's still bigger. Compounded more often when everything else stays the same should mean a bigger final answer. Same formula on part D? Why not? It says continuously, and whenever you see continuously, it has to be this word right here, not some form of continues. It has to be continuously. We use what? We use E. So what is that formula? Yep. A equals P times E to the power of RT. So I have A equals, what's our P value? Still 7,000. That didn't change at all. What do I put after the 7,000? E to the power of 0.054 times what? Times 4. I'll pop that in my calculator. Is it bigger or smaller than our other answers? Bigger. Lots bigger or just a little bit bigger? Little bit bigger. What'd you get? 8,687 and 72 cents. 71, 72, you can round it either way. So it's right about $1 bigger than part C. Do you guys have any questions for me on the back side of this page here? Right. What'd you say? Good. Let's go look at, yes.
That dollar sign, if we don't put it there, will you count it wrong? Because I know
Nope.
some teachers did that.
No, if you don't put a dollar sign, I'm not going to count it wrong. You would still only go out 2 decimal places. Don't give me more than 2. But if you don't round it the same way I round it, and so you're off by a penny or 2 from me, I'm not going to count that wrong. Now, if you're off by more than a couple pennies, then you probably typed it into the calculator wrong, and that would cost points. Let's flip the page and look at number 8. Do I need a formula for number 8? Do I need one of the formulas from up at the top for number 8?
Wait, no, we didn't. No, you just walked.
We're just going to do the operations that they're saying, right? I need formulas for story problems. Whenever you have a story problem, we're going to use a formula. What does it mean for something to be to the 4th power? Multiply it by itself 4 times. So everything inside the parentheses is getting multiplied by itself 4 times. How many times is 7 being multiplied by itself? 4. 1, 2, 3, 4 times. So I have 7 to the 4th power. Can I pop that in my calculator?
Yep.
Yes, I can. What do you get?
2401.
2401. You can't separate an exponent from its base. Do we have something that has an exponent on it? What is it? 6x is my exponent. E is my base. This is the thing that has an exponent on it. 7 is a coefficient out in front. 7 doesn't have an exponent, but the E does. You got to grab that whole thing because you cannot separate a base from its exponent. How many times is that being multiplied by itself? 4 times. So E to the 6x is being multiplied by itself 4 times. How do I handle it when I've got 2 exponents, one inside the parentheses and one outside? Times it. So what is 6x times 4? 24x. So I have e to the power of 24x. That would be my final answer here.
My brain just broke.
Your brain just broke?
Who created numbers? It's like,
Well, we'll start with counting has always been an important thing since we became a society.
like numbers are like every.
Yeah. Numbers are everywhere. So being able to count things, being able to add stuff, being able to subtract stuff, multiplying and dividing, and then it kind of grew from there. Yes, sir.
Somebody just makes on part B. If the E has nothing, it's automatically a number.
Yes, good point. Guys, did you hear what Jayden said? He was looking at the E on the bottom of the fraction here. And he said if the E doesn't have an exponent with it, it's automatically what number? A 1. When I've got these on opposite sides of the fraction, what do I do with those exponents? We subtract them. When do I add them? Yeah, when they're being multiplied together, but the bases are the same. When I'm on opposite sides of a fraction, yep, we subtract those. So I get e to the 9th power. Ladies, save it until later. What do I do with the negative 75 and the 25 out in front? Those we're going to divide. What do you get when you divide those two? Negative, how much? Negative 3.
37. What am I dividing? Oh, that's a 25. I thought it was 2.
Yeah, sorry, it got cut off by my little pen there. Right. Kaylin, did you have a question or you just? Okay. For number 9, do I need a formula from up at the top? Yes. Which one am I going to use on number 9?
The third.
Third one. Why am I using the third one? You're absolutely right, Dwayne. It doesn't say continuously, and it also doesn't say what? Compounded. Use this one when you don't see the word compounded.
So when you don't see either,
When you don't see compounded and you don't see continuously.
I wasn't listening when you explained. What does the line under the plus sign mean?
What does the line under the plus sign mean? It means minus. We have to pick one.
Oh.
All right. When you don't see the word compounded, we use this one right here. So that's what I'm going to use on number 9. A equals P, and then parentheses 1 plus minus R to the power of T. What's the first thing they ask me to do? Write a function rule. What do I have to have in order for it to be a function rule? What has to stay letters? A and T must stay letters. All right, so I start my function rule with A equals. What do I put after the equal sign? Yep, a p-value. What is our p-value here? 15,000. How do you know? It's the principal. How do we know it's the principal? What was the tip-off? What kind of keyword let you know? It's what she started with. It said she just started a job. 15,000. Okay, then parentheses and 1 plus or minus. Plus, why? Received, but there's also raise. She receives a raise. Use plus. What are we going to put after the plus sign? 0.035. We divide by 100%. 0.035. That's our value for R. And then I still need what?
The time.
The time. What do I put for time?
1.
t. Remember, when we're writing a function rule, t has to be part of that function rule. Not necessarily. Nope. That just tells me that it happens every year. That she gets this raise every year. So how do I do part B now? We're going to substitute in a value for t. What value am I substituting in the place of t? 6. She's in this job for 6 years. Oh, I wrote t again instead of 6. There we go. And now I can pop this in my calculator. 15,000, parentheses, 1 plus 0.035 to the power of 6.
18,438.
Yes, 18,438 and 82 or 83 cents, depending on how you round it. I want to get through the last 2 problems on this page, and then we'll cut it off and we'll do the graphs tomorrow. All right? We'll just save the graphs for tomorrow. Do I need a formula from up at the top to do number 10? Which one? The one with the E. Why? It says continuously. So we will use E. So A equals PE to the power of RT. Says we're writing a function rule, so what do I know? But when it says function rule, I know my final answer has to look a certain way. A and T. What's special about A and T in a function rule? Yes. They stay letters. All right, you guys were just like a step ahead of me there. So A equals what? 1,300. Here's P. What do I put after the 1,300? E. What do I put next? 0.029. We take this and divide it by 100%. 0.029 is R, and you're absolutely right. We do that times T, which we leave as a letter in our function rule. To answer part B, here's where I actually start subbing things into my calculator, popping it in there. So I have to have something to put in for T here. What do I put in for T for part B? 4. So I take it times 4. Remember, that has to be in the exponent. What do you get when you put that in the calculator? 1,459.89. All right, last one I want to do today, number 11. You buy a football helmet for $110 and get it signed by Drew Brees. Who's Drew Brees? Anybody know? Anybody ever heard of him? Drew Brees used to be a quarterback. Quarterback, football player. He was quarterback for the Saints, and he played for Purdue before that. So, yeah, he played for the Saints. Yep.
Does he play anymore?
He retired. I don't remember when he retired, but he played for the Saints a couple years. He was the quarterback that led them to the Super Bowl when they went a couple years ago. Don't ask me how many years ago. But they went to the Super Bowl, and he was their quarterback. Honestly, I don't remember whether they won or lost. I just remember he was the quarterback, and I liked him because he played for Purdue before that. So, the value increases 4.5% each year. Part A, is this showing me growth or decay? Growth. What keyword told you that? Increase. So it says increases. Function rule. Which one of the ones from up at the top of the page are we going to use here? The normal one. So which one of these? Third one. This one right here. Because why? Doesn't have continuously, annually, monthly. Does not have the word compounded in there anywhere. All right, so we're going to use A equals P times 1 plus or minus R to the power of T. So I have A equals what? 110, that's the starting amount. Parentheses, 1 plus 0.045, because we have to take that percentage. Yes. 0.045 is our rate. Close the parentheses, and it's to the power of t. Why did we not put 3 in there? It's a function rule. T has to stay in the function rule. For part C, what do I need to do?
Replace the T with 3.
Yes, we're going to replace the T with a 3 here.
What is that, bro?
To the power of 3. Guys, let's finish out this last problem. We'll save the rest for tomorrow. You said 125.53. If you put 52 cents, I would accept that as just as correct as 53 cents. Do we have any questions? Cool. We'll do the graphing problems tomorrow. There's no bell work tomorrow, so if you want to turn the bell work in today, that's totally fine. You can turn it in tomorrow also. Tomorrow we'll do those 2 graphing problems, and then you guys have the rest of the time to study. People that want to work on corrections may work on corrections during that time as well.
I had the ones from